Oh, hey. Sorry. Gonna be a cliffhanger, I guess. Made a goal of more reading over break, so just really getting into it. Day three, but almost done. So anyway, hey, I just wanted to kind of take a minute and touch base and try something new rather than posting things daily, as I know some teachers are. I want to just try to lay out like the scope and the sequence of this week, what we're going to focus on, as well as kind of conclude what we started with last week, which almost all of you completed. Very proud of you, those that did. Not so much of those that didn't, and really frustrated with those who can't log into Google Classroom or sign up for school. Okay, so let's kind of take a peek see here. I got a couple of different things. I hope this isn't a long video, but I do want to highlight a couple things that we looked at. So this was the assignment that you guys did last week. So this is the answer key here. A little bit of history in the writing of this class, real quick, is we were writing this in 2014, and this assignment, as written, was let's take a 5-gallon bucket. And then let's try to calculate out each of these different categories, right? So the 5-gallon bucket represented all of the water on Earth. And then what we had to do was try to decide, how much of that water is, each of these categories. So like, oceans are going to be like 97-ish% of all of that water. What would be the best medium? It was meant to look at precision and accuracy. What would be the best medium to actually measure out, to equate it to how many, milliliters of water? What would you use to do it? Then you dump it in the bucket, and it's just trying to show the very very finite amount of water, specifically fresh water. When you're getting into things like rivers, like let me just highlight that, boop 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 boop, right, where you're using a micropipette to represent what rivers are in the scheme of planetary water distribution. But the the ironic thing is this whole sequence is talking about how precious fresh water is, and how we should conserve it. And this lab just basically has us all fill up a 5-gallon bucket of water per lab group and then just dump it down the drain. So in areas that are teaching it, in like California in 2014, severe drought, we put the kibosh on this and we just did it analytically. No way to really model it super well. So the biggest piece that we should take away, is all of the stuff that we tend to want to protect, the lakes in Minnesota and the rivers. If we're actually looking as a usage standpoint, they really comprise a very, very small amount of the water. If we're looking at how we use it, it's a really, really small component, when really groundwater is the biggest thing or our biggest source of human use, whether it's for drinking, whether it's for domestic use, whether it's for irrigation or anything like that. So one of the things had you guys look at, which areas are for human use, and it's those three. It's fresh water, fresh groundwater, rivers and lakes as well. But in the scheme of this stuff, I mean, we're talking very, very, very small amounts, that comprise everything that our species and really, most species on this planet have to use. So, the urgency to protect and to conserve, and to kind of keep clean, is there as we start to look at some of these other methods that can contribute to pollution issues surrounding these things. So if I pop this thing up for a second and look at this real quick, just again, I'm a visual learner, so I like, the numbers, my eyes kind of cross a little bit, when you're looking at the 0.00012 whatever. But I did want to kind of look at this is again, I mean, just graphically representing exactly what we did. 97% of all of the water on Earth is salinated oceans. Only 3% about is freshwater, and then of that 3%, 77% is inaccessible. It's frozen in either permafrost or icebergs or whatever else. 22% then is groundwater. 1% are those lakes, rivers, and streams. Again, looking at this, again, another graphic representation, same type of thing, is like of this 2.5%, 3% freshwater, you're looking at 30.1% there. And then of this surface water, this 1.3% of the 2.5%, most of this is still locked up in ice and snow too. So let me move me out of the way there. You have all these different subcategories depending on who is doing the study and stuff too. So we're talking, I mean, what we rely on is such a small percentage in the entire scheme of everything that we're looking for. So, that's just another important component too. And then how we use these freshwater resources. Home use, domestic use is really only 8% of all of the freshwater that human beings use, whereas the vast majority is irrigation, and that's specific to agriculture. So, I do like to kind of look at, man, ways that we can positively impact the environment. And something that people point to a lot of is like, oh, I could take shorter showers, or I can only wash full loads of dishes in the dishwasher. And yeah, that's good, but in the scheme of things, man, that's it's contributing very, very little. Like better decisions, if you care about water resource management, would be looking at where you buy your food, how that food is produced, and so forth. And we can get into some different irrigation strategies. Okay? So that's kind of laying the groundwork for what we're going to be doing going forward. The first assignment for this week, and it's really kind of a research-ish project, and I'll talk about a couple of these components too, is looking at areas that are experiencing a global water crisis of some sort, like looking at how water or water resource management is causing some stress in some different areas. So it can be things like pollution issues. It can be things like drought. It can be things like just lack of water from a maybe political or militaristic standpoint. Is there a crisis? Is there a military conflict that's causing people to be water insecure? And that's what you're going to zero in on. Now, as written, this project is a group project of 2 to 3. Again, given the scope of what we're doing here, I'm going to be super flexible on that. So some people might want to go solo on this, and that's 100% cool. If you guys want to form, I was thinking of class dojoing it and just putting you guys into groups. I'm going to let you guys kind of have user's choice here, and maybe pick some groups if you want to do it. It's written as like a written research project. We're going to submit it as a Google slideshow. Okay, so if you guys can, collaboratively put together a project as a group or as an individual and submit it to me, that would be awesome. But this document that will be posted, it gives some background info. It gives some places to start. I'll show you that in a second. It's a case study of a real water crisis issue. So you're going to pick a region, a country, an area, maybe even a historical event. Like it doesn't have to be current. You can look at, cholera in London and what was going on there historically, where drinking water was actually poisoning people. Or you can look at a current event like Flint, Michigan, or you can look at a disaster that happened in Haiti that caused freshwater resources to all of a sudden be insecure, or just drought issues in California, something that was affecting my grandparents pretty drastically. So, it talks about selecting a region, doing some research, and then it kind of walks you through like here are some of the major requirements. Is what is that country like? What is going on there? What are the health problems and diseases there? What are the number of people impacted? Where do they get their drinking water? What is the cause of the contamination or the crisis or the lack of water or whatever else? And then what are some of the factors influencing that accessibility? And then the biggest piece, or maybe a big piece, I shouldn't say the biggest piece, but what are some ongoing solutions that are looking at being implemented to address this region? And then how do engineers play a role in that too? So what is being done? What are some engineering solutions to this crisis? And so forth, okay? What we're not going to stress about is obviously, we're not going to worry about these engineering notebook questions. Notebooks are kind of up in the air right now, so probably not doing that. But I do like them because if you're looking from a project lead the way standpoint, like this is what is trying to be emphasized. So use those questions to guide your research too. It says a 5 to 7 minute presentation. I'm not going to make you guys present these. I thought about like, oh, you can present and film, and then let's not even worry about that. So you'll just submit this as a Google slideshow. So that being said, just make sure that you're really clear. Like I hate wordy slides, but because you're not presenting and able to fill it in vocally, just be really concise with what you are trying to communicate. I am going to post all of these then, so we can kind of look at these because we'll be pulling bits and pieces of information off of this as a group as well. And then don't sleep on this one either. Just APA guidelines. That's all in kind of science writing, science courses. Is citing your sources. Okay, so again, let me know as soon as you guys pick a topic. Maybe email me who you are or like who's I know who you are, but like are you guys working in a group? So give me the names of everybody in the group, and then what is your topic? Okay, so just give me those as soon as you pick those or pick that topic, and then we'll go from there. So that's going to be a couple days of research and doing that. We'll be flexible on the deadline. We can touch base midweek again and see where you're at. I do want to show you this. I think this is going to be fun and very abstract from a distance learning standpoint. But one of the projects that we used to do, and I still want to do it because it's fun. I mean, this whole thing is looking at what is drinkable water and what does it mean when water is potable or drinkable, and what does it mean when it's not. So I'm going to have each of you build a filter using recycled, discarded, or just stuff that you have around your house, okay? The way we used to do this is the constraints was everybody had I provided a 2-liter bottle of water and then just miscellaneous stuff like coffee filters, cloths, cotton balls, things like that. Please don't use any N95 masks, not the time. But people would use face masks in the past too. And other things too. We would then have a standard bucket of contaminated water. Everybody got like 500 mils of that contaminated water. They poured it through their filter, and then they were graded on water clarity and water quantity that was resequestered. So here's an actual snapshot of some of these filters that resulted. You can see the water in certain cases came out dirtier because they tried using different types of particulate matter to help create a filter, and that came out pretty well. You can see. Others look very drinkable. Others, like nothing went through this one. You can see that one's pretty low, and then these ones are kind of standard. Now, some flexibility here is you're going to have to, I am going to use Flipgrid as a demo here because I think it'll be super fun. So by the end of the weekish, like build a filter, and we'll have a Flipgrid prompt up there to submit a demo. So not only you just describing what you use in your filter, get some contaminated water. I don't know. We'll be flexible here. That can be stuff like just taking water, adding things like, I don't know, cooking oil. If you have like cocoa, that makes it look super contaminated. That's kind of cool. You could grab dirt or whatever else. So this isn't going to be an equal project in that everybody's going to kind of have a different starting point. But the goal is to kind of see an improvement in the before, pour it through the filter, after it. I think Flipgrid will be kind of a cool medium to do that. I'll really try to, I'll get a document out there soon to kind of structure it, but I just want you to get your wheels turning. Start looking before you start throwing away materials, containers, buckets, filter material, or anything like that. Maybe save them for this project too. And again, total flexibility here. The goal is to just see what you can do given these constraints, and then go from there. So guys, it's like what, 13:30 of me talking at this point. Hopefully that kind of lays it out. I'll get all this stuff posted really soon, and we'll kind of keep going. Let's touch base maybe midweek and see where you're at on the projects. I'll open up that chat room, or I'll provide like a Google feedback form or both maybe, and we can go from there. So let me just say again, flexibility is the name of the game here. We're going to have some fun this week and see where we go as we start to focus on water research. Bye bye. I'm going to get back to the book.